Hi, everyone. Welcome, and thank you for joining us for the 2020 Hackaday Prize Dream Team final presentation today. We're so excited to hear about all the progress that our UCPLA Dream Team has made over the last couple of months. My name is Magenta Strongheart, and I'm Head of Design and Partnerships at Supply Frames Design Lab. This year, for the Hackaday Prize, we did something totally new and worked with 4 nonprofit partners to develop challenges for a 2-month engineering sprint where we essentially recruited top innovative talent around the world to join our dream teams and solve these nonprofit challenges. Today, we're going to be reviewing the work of the United Cerebral Palsy Los Angeles Dream Team. Of course, none of these amazing open source projects would be possible without the contributions of our generous sponsors, SupplyFrame, DigiKey, Microchip, and ARM. So we'd like to first give a huge thank you to them for their support of this initiative. Without further ado, I'm going to pass it off to Giovanni Salinas, our product development engineer, who will give us an introduction to the challenge and our panelists and team members joining us today.
Thank you, Magenta, and hello, everyone. I would like to start by thanking our UCPLA panelists for being here today. Stephanie Anderson, Director of Growth and Innovation, JJ Levenstein, Chair of the Board, Amy Simons, Chief Development Officer, and Rania Kerr, Adaptive Design Manager. So we're here for the final presentation of the UCPLA Dream Team Challenge. The team includes Reuben, Calvin, and John, who joined us a couple months ago. Hi guys, hi everyone, and thank you so much for your dedication. I also want to give a special shout out and thanks to Larry and Chris for their willingness to help us test the devices. It was an incredible experience to see the products being tested by actual users. And well, if it was an amazing experience for me, I think the team can relate even more. Without their participation and feedback, this would have not been the same. So designing a product in the middle of a pandemic and thousands of miles away from each other requires a special kind of commitment and talent. So I'm really excited to pass the microphone to the team and see what we have. So the floor is yours, UCPLA Dream Team. And thanks again to everyone for being here today.
All right, good afternoon, everyone. Thank you for taking the time to join us today and to wrap up our final presentation. And thank you to Aragna, Stephanie, and everyone at UCPLA for helping us along the way of this journey. And with that, I'd like to present our final prototypes we've been working on to assist the UCPLA community for accessing digital devices. So to give an outline of this presentation, we're going to first start by giving a brief background, then go into the 2 prototypes that we have been developing. To relate to this project, what we understand about the UCPLA community is that it's very diverse in more than one way. Everyone is unique, whether that be their physical limitations, their daily routines, or their user preferences. We've also come to learn that commercial devices available for these users are not really designed for them. Among other reasons, this could be due to a combination of the high price point or the difficulty for users to adapt to different commercial devices due to the limited options out on the market. The lack of options prevent users with cerebral palsy and in general other people suffering from different disabilities from using digital devices, which really limits their individuality. So a few design goals are listed here, some of the important ones being affordability, scalability, and being able to adapt to different users. So some of our project goals are to deliver a few products that are easy to set up and work out of the box. And for us, we've really honed in on controlling a Roku for this initial proof of concept test. But we also want to have our products work on a larger platform, on a larger scale for universal control of different IoT devices. So with that, we're going to first start with talking about the gesture control remote. And in the past presentation, I think I called it a motion sensing joystick. And maybe I might refer to it later on as an IMU device, but these are all sort of the same device. And we still need to figure out a name for it. The initial concept of this device was inspired by watching the videos of UCPLA artists painting with different parts of their body using your 3D printed adaptive painting tools to make the paintbrush an extension of a user's extremity. With these images in mind, we wanted to apply this concept and replace the paintbrush tool with a wearable electronic device that can detect the changes in motion of the user, where we can then process these signals, communicate with different electronic devices. The first proof of concept test was to draw images in Microsoft Paint using these wearable units to emulate a Bluetooth mouse to draw an image like this. About a month ago, as Giovanni mentioned, we delivered our initial prototypes to UCPLA, and thanks to the coordination from you guys, we were able to see our initial prototypes in action in one of your facilities with Chris and with the help of Larry. So we were able to see Chris use this gesture control remote to navigate through a maze on a computer. So being able to see someone with cerebral palsy interact with their devices was both fulfilling and also valuable to understand how we can improve our system. So briefly, some key takeaways from this first session was that there's an obvious learning curve to using a new system for the first time from both the user and a caregiver perspective. Second, we can clearly see the reliance of muscle memory instead of visual feedback to use this specific system, which is preferable for users with visual impairment. So next, Larry and Chris brought up during the session that using this device was some of the most active motions he's done in a while, leading to the possibility of using just the system as a physical therapy tool for exercise and expanding range of motion. And finally, the last takeaway for me, which is the most important, our biggest challenge of this project is, in my opinion, not a technical challenge, but rather how we get users to adopt new technology. So sure, we can make something that's cool, has utility, and is really tailored for this community. But if we don't make a good first impression to the user, then it's easy for that user to just discard it and never try it again. So the first training session with Chris, there were some rough patches where he would move his arm in one direction and then the system would respond differently. And this can cause frustration to build up. And if our system doesn't work on the first try, then there might not be a second try. But in Chris's situation, I think what really helped him was that he was playing a fun and engaging game that was giving him positive reinforcement to continue to focus and work through his issues. So with this system, there will be some frustration that comes with learning a new interface and a new system, which on our end, we have to do our best to mitigate this before we get it into the hands of new users. And another way we can limit the frustration is to associate these devices with fun, enjoyable activities, such as playing games, or if there's a focus on fine arts within the UCPLA community, then maybe the first impression should be to use these devices for a program like Photoshop. Then once we get all the kinks worked out with engaging activities and applications, we can then move on and ask them to do other useful applications like controlling smart devices. So in the months since the testing session, there's been some developments that we've been working on. So I'm going to first talk about some of the hardware updates. So here are two images of the updated prototype that we plan to deliver very soon. So one task was to improve the battery life. And in the testing session with Chris, the wearable device was always connected to a power supply. So it was always tethered and it sort of limited his motion. So now we've incorporated a battery that lasts up to 6 to 8 hours between charges. The second, we included a vibrating motor in the unit to incorporate haptic feedback in addition to visual feedback. This is done so that there are multiple feedback pathways for the user so that this device can be used with a larger percentage of the cerebral palsy community. So anytime a user changes their position, they will feel a vibration. And we're still playing around with encoding different vibration patterns for mapping to different actions. So lastly, there's one big button here on the wearable unit, which allows for toggling between different output devices, such as from a computer to a TV. So one way a user can press this button is by using their other hand and pushing it, or they could press the button up by pushing the device against a hard surface with that same hand, so that if it's someone sitting in a wheelchair, they can push it up against something like the side of an armrest. So as far as gesture control remote goes, here are the list of components that are required to make one set. So one set consists of 2 items, the gesture control remote itself, and also a dongle. So the wearable unit itself includes all these components, and the total cost of these is about $25, and they're all encased inside of the housing. And then the dongle is used for signal processing and communication with other devices. And it doesn't need to be connected to any other device that it's controlling other than a power supply. And on the software side, a lot of items are not as straightforward, and our current approaches still need some fine tuning before deciding on a direction. The first discussion topic is how do we expand the number of buttons? And what I mean by this is in the gesture control remote that we sent out to Chris, we asked him to have 4 positions to move up, down, left, and right. But then if we want to use this device to emulate a Roku remote, which has 20 buttons, it becomes a little harder to have 4 positions mapping to 20 buttons. So for increasing functionality, one way we could do this is we could ask the user to wear multiple gesture control remotes. And I think that's still an option, but I remember when we first brought this idea up to Chris, there was some resistance to doing so, as he wanted to just focus in on using one device first. So what we've settled in for our current approach will be showed on the next 2 slides. And I'd like to introduce this by starting with an analogy of using a computer mouse. So with the computer mouse, if you have the left click button and you single click and you double click, those are 2 different actions. So essentially you have 2 buttons using 1 button. The next concept relates to using the right click button, where in almost any computer program, if you click the right button, a menu comes up with more options to select from. So since each item in this menu acts kind of as their own button, now you have more functionality with just a left and a right click button. So using these 2 concepts, we can increase the number of buttons on our gesture control remote. So for single click actions, up, left, right, down, it controls the Roku arrow keys. Now, if we want to have other buttons, then we need to use this expanded functionality using sort of this double click idea. So in each position, say if a user does a double click, meaning that say you were to move up and then back down to a normal position and then go back quickly up to up position, then it would trigger a secondary function, which in this case would be selecting the OK button on the Roku remote. So now if we did a double click to say the left position, then it would open up a submenu. So then within that submenu, then you would be able to have 4 new positions, meaning access to 4 new buttons. And in the next slide, I'll show a video explaining more clearly how something like this would work. And there's kind of a lot going on in this video, and I'd like to sort of set it up before playing it. So in the top left here, I'm wearing one of the gesture control units on my arm, which I first used to play the maze game, which is something that Chris has done before. And then after that, I'm going to press the button on the wearable unit, and then it's going to switch over from the computer to the Roku on the TV. And then I'm going to navigate with the arrow keys to a Netflix and play a show. In the bottom corner, there's the wireless dongle here that's showing a visual display where the colors change based on different actions. And through this video, it's easier to show visual feedback rather than haptic feedback, but both are happening simultaneously. So hopefully this video plays. Right, so this video, it shows this concept kind of working, but what it doesn't show is it took 10 attempts to get this right. So earlier I talked about making good first impression and trying to minimize frustration levels with using the system for the first time. So there's still some tweaking to be able to use this to control a Roku before we send it out. The next topic relates to how we scale our devices to make it truly universal, meaning we can use this different input devices to control any smart device and some other electronic devices as well. So our current approach that we sent with Chris was a single modal approach where there's like a linear path from input to one application. So for instance, for the maze game, it was from this wearable orange unit to an intermediate receiver, sending signals to a computer. So this single approach is good, but we want to have a system that's kind of mapped out like this. To make the system truly universal, we need multiple input devices a user can choose from. That's connected to a hub that can connect to many different integrations of smart devices and other electronics. So starting on the left with input devices, we designed two low-cost devices. The IMU remotes or the gesture controller units. This is the keyboard that Reuben and John is going to present later on. And then also, we can also leverage the idea of having an open source platform to integrate other open source projects. So this is a project by another Hackaday user, the harmonica like Magpie MIDI controller, which when I look at it, it's something that we can integrate with this platform as well. So at the beginning, a user will choose the device that is most suited for their situation and only use one at a time. But once they get a handle on one device, then they have the ability to not just use one, but maybe two or three of these in combination together so that they have greater control of different smart devices. To help us communicate between our input devices and the smart devices, it makes sense to use an intermediate hub that receives an input command and relays it to operate the correct output device. And in the video I showed in a few slides before, the hub that was used was a standalone Raspberry Pi with a software called Home Assistant installed. And this device would be plugged in somewhere in a household and connected to the Wi-Fi, where all the devices, both input and output smart technology, would be connected to it. So if you had multiple users with multiple input devices inside a UCPLA residence, they could all access all the smart devices at the same time through this common hub. The different smart devices that can be accessed need to be pre-configured to our system currently, and it requires some technical knowledge to do so, and in the future we need to think about how we can make this process more user-friendly. And to wrap up at least this section of the project, the future developments that I think we still want to work on is kind of open-ended, but some of the things that we plan to do are to deliver the prototypes that we've been working on that are in our hands and give it to you guys. We need to work on our project documentation and upload it to the Hackaday project page, as well as include user manuals to how people can set some of these systems up or make their own. And then one application is that I want to continue developing that's for UCPLA specifically is using the system for lightweight use of Photoshop or other graphic software that so for this, I would think I would need a user to be able to handle two devices, where one device is doing a lot of the active movement to kind of emulate sort of like the mouse moving around, and I would need another device that can just be used to have at least a minimum action of one device, or sorry, one action. So finally, using this platform for sending emergency notifications is something that we briefly internally discussed, but I think it's important to have a component of this system, sorry, a functionality incorporated in the system. So a goal of this system is to give individuals more individuality, meaning they have less reliance on caregivers. So if our system is successful, it means there will be more physical distance for extended periods of time between users and caregivers. And to give both parties peace of mind, we would need a way for users to stay remotely connected. And so a user should be able to quickly send a text message or send an email to notify their caregivers that they need attention. And this function should be able to seamlessly integrate in our platform through our input devices. And with that, I'm gonna hand it off to Reuben and John to discuss the second product that we've been working on.
The adaptive universal remote, or we've originally called it the keyboard because we're basing the hardware that's using it is pretty much built similar to the way a keyboard is. And the idea is that it would eventually be able to be scalable, as Calvin pointed out, to do more than just control Roku TV. So the initial concept was to create a keyboard, and the keyboard we came up with was more of a test unit to display different kind, or to try different kind of buttons and sizes to get a feel for what the user preferred, and then try to expand the usability of the device. We created a display to go with it, and display was supposed to be a cheat sheet to let the user know which button is performing which function at any given moment. In actual testing, that concept didn't come across as clear, and I felt like the users had a harder time making that connection. For whatever reason, I'm sure there's some design changes we could do to make that better. Unfortunately, we didn't have time to pursue this option further, and we ended up going in a slightly different direction, but still keeping the keyboard. Next slide, please.
Sure. Thanks, Reuben. And thanks, Calvin, for the introduction and everything that you had described there. I think it was really awesome. And I think I want to express how excited we are to see a product like this actually be used by somebody who would benefit from it. So based off of what Reuben was saying, our initial concept, which you can see in the top left image here, is just a test keyboard. We test different shapes of buttons and different sizes of buttons to see what a user might prefer. Now, we had tried to pair that, like Reuben had said, with a screen, but it seemed like there was a disconnect between using the screen as an overlay for what function those buttons had, and it seemed more like the user was hoping to just interact with whatever was on the screen. So with that being said, what we had ended up deciding to do was to do away with the screen part of it and to just create a remote that could then be interfaced either with having the buttons have set functions that we can pre-configure ahead of time, and then have those buttons work with a specific device or a specific set of devices. So on the bottom, in the bottom image here, you can see our new concept. Now, one of the things that we had realized after getting feedback from a couple of users is that having the board lay flat made it kind of hard to press some of the buttons depending on how a user was positioned or what appendages they're able to utilize. I know that one of the users prefers to actually use the remote by pressing buttons with his toes. And so in order to be able to do that, we needed to have a platform that allowed the user to still see what was going on, and having it lay flat did not allow the user to do that. Now, the concept that Reuben's going to demo has this set angle, but we don't want to limit it there. One of the things we want to do in addition to this is basically add a base that you can adjust the angle or the height of this device so it can be more universal for users' preferences. On the image on the very right, you can see we actually split this into two separate parts. Reuben will actually have a much better, a live looking version of this that we actually 3D printed. But this is our IR blaster. And so the thought was that between the two of these, we'd be able to interface with not only TVs, but many other smart devices, whether or not they use infrared. There are other applications for this. If you have some technical know-how, you're able to reconfigure these to, instead of having the IR blaster send signals, it'll actually receive signals and send that to whatever smart home device you want. But that's something we want to pursue further on down the road. That's all I had to, that's all I had to have, all I wanted to add here. But I want to pass the time back over to Reuben and let him give you a demo. And hopefully you guys can see that this will be something that we will be able to expand on in the future as we continue to develop the software for this, and hopefully get other users in the community able to develop and add to our project.
So I'm going to switch my camera so we can do a quick demo here. and show off the the cool product. So we have our keyboard here. I didn't have time to label it, but we try to make the buttons slightly different colors so that some of the buttons stand out more than others. Quickly to go over some of the features, I wanted to cater to Aragna's comment when we first started. It's like, they don't make cool stuff that are assistive. So we wanted to make something look cool. It has a red backlighting, good, and you can adjust the brightness level. It also has haptic feedback that's enabled. So on that note, the other part of this is the IR blaster. I guess I should look at the camera. And the IR blaster is essentially just that. It's an IR repeater. It's already pre-linked to the keyboard, and all you have to do is line it up to the TV and plug that in. So I'm gonna go ahead and do that now. I have this set up here. We're gonna go ahead and plug this in. And line it up to kind of generally face the TV. And if everything works well, I should be able to turn the TV on. And the reason why we did the IR blaster separate is now it does not matter where the controller is. So we can put the controller here and we can navigate home, and it doesn't matter where the controller is. It does not need line of sight to the TV. And for example, we can navigate over to like YouTube and launch YouTube. Again, the buttons are oversized and a bigger remote, making it easier for people to use different parts of the body to navigate. So, and then you can play videos or turn off the TV. There it goes. All right. So that's pretty much for the demo. If we want to, the last slide I think was just question and answer. So we're open to questions.
Awesome, thank you, Dream Team. So with that, we'll go ahead and open it up to the discussion portion of the event. So any of our panelists are welcome to jump in. And thank you so much for that comprehensive overview. It's really exciting to see how these concepts have developed since the initial presentation.
I just wanted to say it's thrilling, absolutely, as you said, Magenta, to see the evolution of the concepts, but also I want to say thank you so much for working on two different devices at the same time. The team came to us and asked us a very hard question, which was, which one do you want? Giving us a couple of concepts, including another. And it was a difficult thing. We were so excited about the gesture control concept in addition to the universal remote. And the fact that you guys have been able to run both tracks and develop these further is extraordinarily exciting when we look at the vast the very different needs of people out there that we support. It really opens up the opportunities for folks. So thank you.
Hi, thank you again. I would like to echo Stephanie's sentiments, and each of our citizens have different levels of mobility. And Kelvin, my question for you with the first gesture control device is that it assumes a range of motion. I don't know how narrow that range of motion is, because some of our folks may only be able to move in a small arc. They may have spasticity where they have uncontrolled movements that are not volitional. And the question I have for you is, if they have an extremity, including an ankle or foot, that has more control, is your device able to be moved or utilized on all four, or is it just more arm movement and assuming a minimum range of motion? I know it's a long question, sorry.
Right. So the idea of the gesture control remote was to make it adapt to the user and not the other way around, because usually users have to adapt to the technology. So with this device, a user should be able to pick whatever extremity they have the most access to. And then they can either use like a wrist strap or like a knee strap, where they can mount it to like the trunk of their body. And then I think what we didn't show is the calibration procedure before setting up, before setting up for each individual user. So based on each person's range of motion, if they can only move a certain way, then that's sort of the position that we will set our system to. So this calibration routine should be able to configure individually to each person before they use it.
Can it be used on the head too, like a headband?
Yes, it should be able to.
That's awesome. Okay, great.
And it's important to say that for the calibration routine, you probably need a caregiver or someone else there logging the range of movement. And once you're done with that, they can carry on.
Again, I will echo, this is the thoughtfulness that you guys have approached both of these designs is greatly appreciated, and the world will benefit from having our individuals be able to express themselves and introduce themselves to the world in the way they haven't. So it's very exciting what you guys have been doing, and thank you for that. I had a question regarding, do you have an estimate for both of these prototypes, how long it would take for the reproduction of them, and if the cost would be comparable to what they currently are for the prototypes?
I'll get start for the universal adaptive remote system that we have here. It's we try to pick parts that are readily available. So we don't want to create some super custom thing that, oh, now you have to order some special part that's on back order. So it's made with very common components that are used by everyday manufacturers to make everyday products for consumers. So that's why we kind of dubbed this the keyboard. It's essentially using all the same parts as the keyboard. Same with the IR blaster. So the thoughts, let's see, trying to think of the cost estimate should be, I guess a preference with, if you mass produce it, it'd always be cheaper. So this totally has the capability of being mass produced. At the moment, if you were to build it the same way we did, it would cost, I'd have to look at my spreadsheet, but I believe the keyboard itself costs about $40 for all the components. And then the R blaster is only $20. So total $60 for this unit. And that's just for parts. So, and that's just buying in small quantities. I'm sure if we bulk ordered, we could get that price down.
And the programming is there ready for it to be used. So it would need some tweaks maybe, but that's also a very important part that mass produced products would need to factor in. But now we have a good progress with that.
Well, the scalability of those price points already is tremendous when we compare that to the kinds of things that folks actually have access to right now. So that's huge.
And I wanted to hear from Kelvin too on the same thing.
Sure. So for the gesture control remote, the initial, just the input device itself, it was $35. So pretty much around the same price of the keyboard, as far as like the cost go. But there's different like products associated with running our device. So if you wanted to set it up within like say a facility, then you would need maybe another $30 to have that common hub that's being accessed to like, different devices. And then for each of them, like the smart technology integrations, whatever like users want to do different things, whether it's Roku or having an Amazon Alexa, an Amazon Dot, whatever they want to do, I think there's an initial cost with that. But these devices are to be able to integrate it with like off-the-shelf components that are still around those price points. And regarding the time for reproduction of our products, I think if I'm being honest, it's still up in the air because we're not really sure like what the pathway forward with like supply frame or how we're going to proceed with this yet. So I think that's still up in the air for now.
If I can jump in here too, I just wanted to add a little bit more on the cost estimate side of things, or sorry, not the cost estimate, but the time estimate. To give you guys an idea, 3D printing is kind of the way that we went for the majority of our products, which is an amazing technology, but it is a little bit slow when you are waiting for production. And so I think that would entirely depend on how many devices you're wanting. If you want to scale it up, I think we should move towards injection molding, which would be much more cost effective in the long run, but would be a large cost up front. As far as 3D printing goes, to give you an example, the keyboard and the buttons together, we'd be able to produce about one every 24 hours. Just the housing and all of that. If we want to make any modifications or add stands, stuff like that, that would, of course, take extra time. The other thing that I wanted to mention, and I don't think we discussed this in the presentation, is that even though the keyboard, it comes pre-paired with the IR Blaster, we made that choice because it will then work with any TV, and you can program it so it can learn signals from whatever TV you want. That being said, if it's a smart TV like Roku or some other device, the keyboard has the capability to connect directly through Wi-Fi to that device. So you don't have to consider it as $40 plus the $20 for the IR Blaster. They could technically be two separate units.
Yeah, fair point, John. I forgot to demo that. Essentially, the final product that we're trying to deliver will have a learn function. So pre-programmed. We also have, we bought enough components to deliver 3 keyboards, IR Blasters, and Roku Express. So we're going to be delivering 3 of these to UCPLA. It comes with a Roku, and the only thing you would have to program, and we created a learn functionality where by pressing a function button and then one of the other buttons, you can put that button into a learn mode. And then you just take your regular remote and you point it at the IR Blaster and it learns the code. So we're trying to make this as user-friendly, no external software. It comes ready to go out of the box. Trying to make it as easy as possible for the user to set up, which was kind of the shift from the display, because it was going to have a very more involved, I don't want to say complicated, but more involved user interface to program and set up and that kind of thing. And then, like John mentioned, is like currently the firmware we worked on, or the product we worked on, is set up to just pair to the IR Blaster, but it's an open source platform. Anyone who knows how to program Arduinos or has done that kind of thing can just plug this into your computer. You don't need any extra hardware, and then download the code from the Git repository from the open source platform, and make changes and tweak it and do whatever you want with it. So,
and I think this is, of course, part of a broader discussion we'll all continue in the future, I think, you know, as far as the pathway and how we want to continue to collaborate with you all. But I think it would be useful to, I'm going to put Gio on the spot, to just go through sort of what the process would be for these 2 devices to get to a design for manufacturer standpoint and ready for, you know, very like zoomed out view. You don't have to get into the nitty gritty, but I think for not only our audience members to understand, but for everyone on the call too, what would be sort of the general big picture steps to get this to be mass producible? And then I also want to just say that I think there's a lot of potential for two routes of collaboration into the future. One I think of immediately, since there are versions of this design from the prototype that could be sort of reproduced through distributed manufacturing within our maker and hacker community, in the same way that, you know, everyone banded together to help with PPE for some of our community members. I think that that's a really, you know, interesting and sort of immediately available option. And then I think that, of course, with Supply Frame's broader network, we would be happy to, we've always thought that we would help, you know, in the future sort of design for manufacture route of this. So we will definitely be discussing that more. But I think it'd be helpful for everyone if Gio just ran through sort of the general, what would be the next phases to get to that point.
Yes, well, I think one of the first steps would be to test the units that Reuben and Calvin are going to send to UCPLA and get as much feedback as we can from those. Tweak them as much as needed. And then, as you mentioned, I think the cheapest step, and this is another thing that John also mentioned as well, go for distributed manufacturing, have a short run of a few units. And when I say few units, we could say 20, 50, even 100 units, that because we can benefit twofold. Number one, front investment is not that high. And number two, we would be getting much more feedback from users with a wide range of accessibility challenges, you know, and then we would go to that next stage of tweaking the design. And that's when we make a decision. Should we go for an even larger set, you know, to keep on testing, or are we confident that this can be mass manufactured, just like John said, plastic injection or something else? So it would be, this is not a straightforward product that goes for out to, you know, to the consumer world. It doesn't need testing. This product needs a lot of testing, but it's really, really beneficial. And with the available technologies nowadays, it's much, much easier. What John said, it's really interesting. We have 1 unit per day, but if we distribute this with 5 different maker spaces, the design lab, ourselves too, then it's 5 units per day, or, you know, it can scale conveniently. So that would be a quick roadmap for me, just to reiterate, test this first units, get as much feedback as we can, then make a larger test of about 20 to 50, and then take it from there.
I just wanted to add something. I'm actually wanted to say, like, I'm very proud of this project. I'm very proud of like working with you guys. Thank you guys so much for, like, I don't know, just hearing everything out and considering all the possibilities and kind of funneling it down to just your final prototype. And, you know, just even like that simple angle of just, you know, not sitting flat on the table, that is very considerate of like the design. And I don't know, like I said, I'm like a proud papa, and like, you know, I'm getting goosebumps just like watching the presentation, and I could also see like the viewer using it and like really like falling in love with it. So I'm excited to like test it out.
We've got several other folks who are ready to help test.
Yes, for sure, for sure. And that's where I'm seeing all the different possibilities.
It's so exciting to think about. Just
yes, and I also want to say, really, I'm also very, very proud of the team. What you guys have done. It meets and exceeds the expectation, because you went from testing a unit, learning from the feedback, and then came up with a solution that addresses those challenges in a very short period of time. And it's a challenge all around, you know, not only the product itself, but the context where we are right now. So thanks again, guys. And also very importantly, now that you were saying this, Aranya, there's another factor that we haven't mentioned. Since this is going to be open source, there might be other contributions to in the next few months that can enrich this product even more. You know, so that's another interesting part of the equation that I'm looking forward to see what happens in the next few months.
Yeah, just seeing all the different possibilities of like the presentation with the mouth, you know, with the breath, and like I think there's so many levels that I don't know. It's really cool. So
well, and you demonstrated that by again starting with the universal remote and then adding in the gesture control option and being able to deliver on that in the same period of time just blows my mind. So
yeah, I wanted to know like the design aspect of it, like the circle. Was that a UCP like kind of logo symbol that you did, Calvin?
It looked like the Matter Hacker or the Hackaday, and then the swirl from UCP. Is that?
Yeah, so I sort of went on Google Images to look at sort of the logo, and I saw some sort of designs. And to me, it looked like sort of like a landscape painting where you have like the ground and the sun. So then these color schemes are sort of like the light blue, the orange, and the green. It's kind of like the earth, the sky, and the sun as well. So I guess this is sort of inspiration, and that sun was just replaced by the Hackaday logo. Yeah.
Yeah, that was
Oh,
also
that-
like another cool addition. Like, you know,
Super
like
cool
that's
and
that's
stylistic.
yeah, I love that. So
I was just gonna say, we had a lot of fun designing this. I mean, I'm sure I had a lot of fun. I'm speaking for myself, but talking to John and Kelvin, I know they both had fun too, even though there were some frustration times. I think the highlight for me is we got to actually design a PCB, and we branded it for the keyboard.
oh,
So
nice.
yeah, so I mean, we have something that's kind of ready for production already. So this is what's inside the keyboard we demoed. We have 5 of these boards. We only have enough components to populate 3 of them, but we could do 2 more and have 5 out by the end of the month.
That's amazing.
So, yeah.
Very exciting. And I think something we discussed on the note of thinking about distributed manufacturing and some of the advantages to that versus mass production is back to that point that Aranya has made throughout this program about sort of making things cool or more individual and custom for each user. So that's sort of an advantage of the, you know, the distributed manufacturing and working with things like 3D printers and that sort of thing, is that you could maybe pick your color, you know, per unit, or pick a few custom icons or designs if we work that into the process, versus mass production, you have to commit a little more to one design. But also I think we've talked even throughout this process about, you know, are there opportunities for decals or vinyl thing, you know, stickers, all kinds of things like that to jazz things up. But I wanted to point out that that is sort of a fun opportunity when it comes to the distributed manufacturing.
That makes me think of when I've never done this, but I know you can go to automotive manufacturers and order a car customized to how you want it. I'm kind of envisioning this being the same way. Customize the color of the LEDs, does it come paired with the motion joystick, and yeah.
Yeah, I would agree with you, Reuben. Go there. I think that would be awesome, you know.
Awesome. So if we don't have any more comments or questions from the panelists, I think we'll wrap up. Or any last comments from our Dream Team members as well?
So I'd just like to once again say thank you to you guys. I think there were a lot of lessons that we learned. I think both technical and non-technical as well, for those for our project. And it's very rare from like an engineering standpoint to be able to so quickly be able to get it in the hands of like potential users. And it's because when we design things, we often we want it to make an impact. We want it to have it in the hands of users immediately. And a lot of times it takes like a really long time. So to be able to do this in like 2 months is like really unique, and it's a really good experience. And so thank you guys, for everyone from Supply Frame and UCPLA as well, for being able to do this.
Thank you again on
you.
behalf of everyone. So appreciate this.
Thank you.
Wonderful.
I think that's a perfect note to end on. Thank you so much, everyone, for the amazing presentation and discussion. We are super excited to continue the development of these open source solutions with United Cerebral Palsy Los Angeles. If you'd like to follow along this project's progress, be sure to check out UCPLA Dream Team on Hackaday.io. And if you want to check in with any other updates for Design Lab, Hackaday, or Supply Frame, check us out on Instagram, Twitter, and Facebook. Thanks again for joining us, and look out for future final presentations from the rest of our Dream Teams.